So let's do the last drill. I would like you to create a class called Kangaroo. And it has, of course, it has a constructor. And the constructor initializes an instance variable called a pouch contents to be an empty list. So now the data associated with the kangaroo is going to be a list, and initially it's just an empty list. Okay, that's it. Now you're going to create a function called put in pouch, and then you're going to create a print function. So put in pouch takes a string as input and adds it to the kangaroo's pouch, which of course is the list. Okay. If that string is not already in there. So if the string is already in there, then print object already in pouch and don't do anything. So if I add something into the pouch, like a bowling ball, and then I try to add a bowling ball again, you shouldn't put 2 bowling balls in, only one at a time. Okay? But if it's not, then you should add it to the pouch, and it doesn't matter where in the list it is. The print function should print the kangaroo's pouch contains, and then print out everything that is in the list. Okay? Good. Again, as always, write a little driver. So create a pouch, print its contents, add something, print its contents, add something in, make sure it got added, print its contents. Try to add something twice. Make sure you get the message saying this is already in here. All right, take some time. Again, full-blown class, constructor, put in pouch, and a print function, and the data associated with this particular object is going to be a list that we will be adding to using the put in pouch. And when you come back, I'm going to show you my solution. Okay, here's my solution. Again, I'm going to separate out the class from the driver, so let's do the class first. All right, I have class kangaroo, I have my constructor, my put in pouch, and my print function. So the constructor is trivial. In fact, it doesn't take any input. It's just self. Why? Well, I said the initialization is an empty string. So self.pouch contents equals open bracket, close bracket, done. Nothing to do. Constructor takes no input. Fine, perfectly fine. Put in pouch, it takes a single parameter's input x, and what you have to do now is add it to the pouch if it's not already in the pouch. So now you got to do a little bit of work. So I've got to go through the pouch and check to see if that element is in there. All right, let's go ahead and do that. For I in range, the length of self.pouch._ contents. So self is the object, and I'm going to grab the pouch contents, which is the list. And I will take on every index from 0 to the length of the list minus 1. And I'm simply going to ask that if self.pouch contents sub I is equal to x, that's what I'm trying to insert into the list, then print already in pouch. And what do I do now? I'm done. Go home. Return. Return out of the function. There is nothing to do here, right? There's nothing to add to the list. You don't have to check any more elements. You found it and you're done. So for every element in the list, check to see if the object exists. If it exists, print a message and boot out. And if I get to this point in the code, after the whole for loop is executed, what do I know? Object's not in the list, right? Obviously not. Otherwise, I would have hit this statement, I would have printed this, and I would have returned. So at this point, I can simply append the object to the list. So let's follow this. Self, what is that? Address of the object. Pouch contents, what is that? The list associated with this object. And that is a list, so I can call the append function with the element that I want. So look at the 3 levels of indirection. Object, data associated with the object, member function of that list. Okay, right there. Good. Let's look at the print statement. This is pretty easy. If the length of self.pouch contents, that is the list, is 0, then just say the kangaroo's pouch is empty. There's nothing in there. Otherwise, say that the kangaroo's pouch contains, and then I'm going to take the list and just convert it into a string, which you can do, of course, or you could have put that into a for loop and printed them out, and then that will print the contents of the list of the pouch, which of course is just a list here. All right, let's go ahead and look at the driver now. So I'm going to create a kangaroo object, call that capital K, and I'm going to go ahead and print it. Let's just make sure that the first thing works, and it'll say the kangaroo's pouch is empty. Good. That tells me that the constructor worked and I have an empty list. Let's add something to the pouch. K.putInPouch, a ball, there's a string, and then print K. The kangaroo's pouch contains, and then it shows me a single object. Let's put something else in there, make sure I can get multiple things in there. Good. So that now tells me that when I put the hammer in, I print K, I get a ball in the hammer. And one more test, let's make sure that it can deal with multiple objects trying to be put in. So if I try to put a ball in, it will say already in pouch. And I'm going to just print that and make sure I didn't screw anything up. So you have to be careful here. Maybe I got the message right, but I still added it. So when I print it, it should only say ball hammer. And really probably what I should do here, because this is testing if the first object in the pouch is an object, I probably should have also tested hammer to make sure I'm iterating through that whole list. So you probably want to drive this a little bit more with a few more test cases to make sure you can find an object regardless of where it is in the list. But again, just basic functionality testing, make sure your functions do what you think they do, because one of the hard things with, well, really any code, but particularly these member functions, is you got to drive them. You got to run them, and you got to test all of them, even if you don't know that when or how they're going to be used. So that testing code we'll see more and more of in the coming weeks to make sure we know how to verify that our code is doing what we think. All right, that's it for now. And when we come back, we're going to have a little bit more talk about objects and classes and start refining some of our thinking about these things. So we'll see you in a little bit.